Good afternoon. My name is Liu Zi'en, and I'm from Tsinghua University. Today, I will present you my proposal for Asian Chinese 0G. And my experiment topic is laser gun-like sounds, the dispersive behavior of a slinky. Here's the outline of my today's presentation. First of all, I will show you the experimental motivation. Since I'm a huge fan of Star Wars movies, I think it's cool if we can remake the laser gun shots sounds in the movie. To make that sound, we can simply take in the slinky and make the gunshot sound. And now I will show you the demonstration video. As you can see, after we take in the slinky made a series of dispersive echoes, which sound like laser gunshots. This phenomenon is caused by longitudinal wave vibrations and dispersion of frequencies in the slinky, which I will further explain in following slides. And I wonder if we can observe this phenomenon under microgravity condition on the ISS. Next is experimental methods. Step 1. Use a clamp or tapes to hold one end of the slinky as the fixed end. Step 2. Attach free waves to the other end of the slinky. Step 3. Hold a hollow cup on the top of the slinky as a sound amplifier. Step 4. Use a steel bar to tape on the slinky to make sounds and observe. Next, I will explain the theoretical hypothesis. Where do the laser gun-like sounds come from? This is because when we tap the slinky on the ground, standing waves are generated because both ends of the slinkies are fixed, and there is a time delay between different frequencies. After tapping the slinky, a series of dispersed echoes travel in the slinky, with low frequencies traveling more slowly than higher ones, which means that we will first hear the higher pitch and then hear the lower pitch. And that series of echoes just sound like the laser gun shots. The figure on the right-hand side represents the spectrogram of a major slinky response from the paper. Each line represents an echo in the slinky after the impulse. You can see that the time required to travel through a slinky is reversely proportional to the square roots of a certain frequency. Finally, is the expected results. When conducting these experiments on the ground, the end of the slinky with weights on can be considered as a fixed end. And as a result, standing waves are generated because both ends of the slinky are fixed. Laser gun-like sounds are made after the tapping because longitudinal wave vibrations and dispersion of frequencies in the slinky. On the other hand, when we conduct this experiment on the ISS, since the end with weights on can no longer hold the slinky, the end of the slinky is hung freely without gravity, and a tape on the slinky may not generate longitudinal standing waves. As a result, we may not be able to hear the laser gun-like sounds obviously. Here's the reference. And this is the end of my presentation. Thank you for your attention.